aromatic in nature, right? It is oily kind of material. It is not miscible with water. So I have what is called iron platinum nanoparticle. Iron platinum is FePt. Okay, I think it is visible, right? FePt is visible. It is one of the magnetic nanoparticle used for many different applications. We will see where we use this one. Okay, you can make iron platinum nanoparticle and then attach this thiol terminated terpyridine to this. So that is what you see here. I have an iron platinum nanoparticle and I attached the terpyridine that I synthesized from my previous slide to this. So now I have a terpyridine nicely functionalized nanomaterial. So just this is only for imagination. We have given as if only one terpyridine is attached to one nanoparticle, but in reality there may be a lot of terpyridine that will be surrounding the nanoparticle. Let's say average of 20 to 50 depending on size of the nanoparticle, you will have 20 to 50 terpyridine unit attached to one nanoparticle. Okay, it depends on size of the nanoparticle. So that is why I have, if you have too many of them, these are the lines that indicate that what it is. Okay, so you have initially iron platinum nanoparticle that is synthesized using a molecule called oleic acid and oleolamine, and that has been replaced with the terpyridine molecule that we synthesized from the last slide. Now I'm going to put that in a toluene solutions. So it will be nicely dispersible. I'm using the word dispersion, not using a word solutions. Okay, there is a difference. If I take a salt or if I take a sugar and put it in a water, then I call that as a solution, right? Because it will be completely soluble. But if I take a nanoparticle and try to put it in some kind of solvent, for example, water or ethanol, or for example, toluene, I call this as a dispersion, because by at any point of time, I'll be able to get back nanoparticle from that by doing simply centrifuge. If I do a centrifuge, I will get the nanoparticles settle down at the bottom, like how your washing machine spins. If it spins at faster speed, you will dry away all the water and then you get a dry cloth. Similarly, if you spin at a very high speed, the solutions will stay at the top as a supernatant, the nanoparticles settle down, and that is why I'm using the term called dispersion. I'm trying to say all this because you are the one who convey these messages to the kids. Okay, so the solution is not as same as dispersion. Solution is completely soluble. If I need to take salt or sugar from a water, I need to evaporate completely water, then I'll get back my sugar. Whereas in case of nanomaterial, I'm calling it as a dispersion, because by doing certain techniques, I can separate the solvent from the solute, right? Okay,
So just
so
related to colloidal solution, like.
yes, it's called colloidal solutions, or in terms dispersions. Yes, you can also use the word colloidal solution. The moment you say colloidal solution, it's understandable that it's a dispersion. Correct. Both
Okay,
the chapter.
thank you.
Okay, so you have a toluene, and onto the toluene solutions, I have dissolved this magnetic nanoparticle. Now what I'm going to do is I'm going to take one of the transition metals. So you know the periodic table, right? Scandium, titanium, vanadium, chromium, manganese. That's where the uh, transition metal starts. If anyone remember, chemistry teacher or biology teacher, I think you all know where it starts, because from
Indium.
you,
with the
yes, from
scandium,
you only we
scandium
learned
21.
this periodic table first, right? So anyway, I'm personally thankful to all of the teachers. So once you add one of the salt, transition metal salt, what it forms is it forms the emulsion. So once it forms an emulsion, that means we know we take a water and oil, or oil in water, we see small bubbles, right? Those bubbles, we call it as an emulsion. Similarly, I can take a dispersion of iron platinum nanoparticle onto which I'm going to add a salt. The moment I add a salt, they will start forming a nice emulsions. I'll show you in the next slide the images of those emulsions. Actually, you can capture the image of the emulsions. In reality, what happens is, this is what is happening. One iron platinum nanoparticle is bonded with a terpyridine molecule. The moment I introduce iron, iron will go and bind with another terpyridine from another iron platinum, right? And it forms a nice network like what you see on your right side. Can you see the network structure here?
Yes, sir.
इन आपका क्वेश्चन रहेगा सर आप बहुत बोलते रहते हो लेकिन कुछ इमेजेस दिखाते नहीं हो. Okay, I'll show you into the next slide. Okay, so this is how those emulsion will look like. Okay, these are some of the photographic image of those emulsions. So the moment I add these iron into the toluene solutions, which is very uniform, homogeneous solutions, I forms emulsion, like water emulsions. So the surface of water molecule or edges of the water molecule is covered with this complex material, or what is called the structure that we saw here. So this is what forms on the surface of those emulsions, right? But if you take a water and emulsion, normally if you take a oil and add a water, shake it, you get an emulsion. How long that emulsion is stable?
So we have to add a emulsifying agent there.
Let's say for maybe
Yes.
15 minutes, 20 minutes, it looks like a ball. Finally, it will settle down at the bottom, right?
Two
Sometimes it
different
breaks
layers.
also. So have you noticed those?
Yes, sir.
Yes. So in this case, since we have a nanomaterial, they have a good surface energy. They make these emulsions stable, right? So I get these are called. Now I'm going to introduce a new term, what is called colloidal zones. Again, don't worry about all these terminologies. So I'm going to call this emulsion as a colloidal zones because the emulsion surface is made of colloidal particle. As some teachers suggested, the nanomaterial can also be called as colloids. Yes, so these are called colloidosomes because the emulsions are made up of now some nanoparticles, and these are connected to each other through this terpyridine that is linked via iron transition metal. So these are some of the transition metal or microscopic image. So if it's a regular material, then I'll be able to look through optical microscope. That is what you see as an image A, right? And if you go to image B, C, D, image B and C is what is called scanning electron microscopic image, and D is what is called transmission electron microscope or TEM images, right? And if you look at this E image, what it shows is it shows these microbes or these colloidosomes are stable for 5 days. After 5 days, it slowly loses the water molecule and it breaks into thin films, right? It collapses. But if I don't add actually these iron salt into that, and this is how it look like. That's the emulsion that normally we form when you take oil and add a drop of water to that. This is what you get on the figure F, right? And this is not stable for 5 days, it's stable for few hours at the maximum, whereas on this colloidosomes are stable for a longer period of time, and once it loses out all these water molecule, it forms a membrane kind of structures. Now tell me where it can be used now. Any idea, any guesses where this can
Sasidarji,
be
please
used?
mute yourself. Sasidarji, sir, disturbance because of Sasidarji. Sasidarji, please mute.
Okay, anybody can guess? Okay, Shashi.
Can use paints.
Yeah, madam, can you please repeat? दोबारा बोल सकते हो, please?
Sir, in paints,
Yeah, in
colors,
paint. So
paints.
basically, what it's you can think of these as a buckets that carry a water, but it's a small bucket like a nano balls, right? These nano balls. Please somebody mute. The nano ball carries these water molecules. So instead of water, I can have a drag, right? If I have a drag, I can use these material in a drag delivery system. As Madam correctly said, if I have a paint inside this, I can use these as a paints. So then I can create what is called self-healing paints. Wherever the paint goes off, this colloidosomes breaks it and then forms a fills up the crack, so you get a self-healing paints. So these are some of the advantages of this kind of self-assembled structures. Okay, and the next one, what I'm going to do is I also take now, if you have water and oil, what do you get at the, you have interface, right? If I take equal quantity of water and oil, I'll get an interface where at the interface I'll be able to see water and oil, right? At this interface I can do a self assembly. What I'm going to do is I'll take a iron salt in a water and then disperse your nanoparticle, basically a magnetic nanoparticle onto the top. So water stays at the bottom, uh, organic phase stays at the top. At the interface, the moment I add a salt, or since already salt is there, they nicely self-assembles and forms what is called a membrane, right? That is what you can see on this image on a glass vial. You can see a pink colored solution, that is your iron capped terpidine molecule, or iron capped what do you call magnetic nanoparticle. At the center you can see in the miscible, right? In the interface you can see the light is pink in color because it is pinkish in nature. The moment I put iron into a terpidine, it forms a pink colored complex. And I think I'm not sure whether it is there in a 12th standard, we call this as a metal to ligand charge transfer complex, right? And that's why it shows the absorption. Anyone knows this? MCLT?
Yes, sir. In
Yes,
class
sir. Yes,
12,
sir.
we teach the DB
Yes, sir.
transition. Because of the color, we explain DB transition, but there is no scope to say this metal to charge or ligand to charge transfer.
Charge
Right.
like ligand charge transfer, the metal ligand charge transfer, ligand metal charge transfer, pi star transfer, many charge transfer spectra are there.
Exactly,
Yes.
exactly. Okay.
KMNO4
Okay.
we explained.
क्योंकि जब मैं
MNO
12th पढ़ा था मेरे ख्याल से हम
DD
लोग
is not
MCLT पढ़ा नहीं है, इसके लिए मैंने पूछा था. Okay, okay, okay. Okay, let's mute it. Okay, thank you. Yeah, this is called metal to ligand charge transfer. So the metal can donate the electron, or ligand can donate the electron. Ligand to metal charge transfer. Either way it can take place. Normally these are called, in general, I'll put it into the general class called charge transfer complexes. Because of the charge transfer complexes, these are colored in nature, right? And it forms a pink color. And if I apply a strong magnet, what I can do is I can actually get them at the near the magnet. If it is a interface, I should apply a magnet at the interface. All these will come as a membrane at the interface, right? But then I added a methanol to break the interface. So I have a toluene and water at the bottom. I added a drop of methanol to that breaks the interface. After breaking the interface, I put a magnet. So I collected all these membrane at the near the magnet or at the bottom of these vials. So if I look at the transmission electron microscope, since we are talking about nanomaterial, normally the microscope that I prefer to use is what is called transmission electron microscope. I can see how nicely the membrane is composed of very tiny nanoparticles. Okay, this is a zoomed in image. You can see they are nicely spherical in shape. They are very close to each other, and it forms a nice membrane. Now once I have the membrane, I can use this membrane to collect, let's say, a magnetic particle in a water samples, right? We use, many of us use RO system. RO is again nothing but a reverse osmosis, where there is a membrane is used, and we can replace some of those RO membrane specifically with this kind of membrane and collect, but only disadvantages, it will collect only the magnetic material. Okay, so if you have a contaminant in water that is from magnetic material, you can use these kind of membrane and collect them because of magnetic forces, right? So that is one advantage that you can think of. So these are some of the studies that we carried out, how long these colloidal zones will be stable. I just want to show again this picture. See how nicely they self-assembles, right? The colloidal zones also self-assemble very nicely. Depending on the concentrations of the transition metal, I can actually change the size or the shape of these colloidosomes. I can make colloidosomes which is of 50 microns, or I can make colloidosomes which are of 100 micron. Only thing is I need to play around with transition metals strength. Okay, the concentration of transition metal will do the wonder. Also, I can change, instead of iron, I can also put a ruthenium, I can put a zinc, I can put a copper. If I put these different metals, they will give you a different structures. Of course, I did not have time to explore all these in the lab, but this is one publication we made it in a nice journal, which is called Journal of American Chemical Society. Okay, so that is one of the publication that we made. So these are some of the sizes of those. Yeah, किसी को कुछ क्वेश्चन है?
Sir, actually, I told that it is called Jack's paper, na sir?
Yeah, it is called Jack's paper. Yes, it's called Jack's paper. बराबर है. Yes. So this is one that is our work. This is one of the work that I took it from the literature. So many of us heard about the term field effect transistors, right? Transistors. These are the transistors they used in a gas sensors. They used in memory devices. They used in some of the semiconducting material, right? And the way they have these semiconductor or field effect transistors, or how it works is it gives you a signal if you have a gas molecule, right? And what I can do is using the different terperidine. So these are different terperidine molecule, one which has got let's say 1 2 3 4 5 6 7 8 9 chain, carbon chain length is 9. Here we have 6 carbon chain length, here we have 3 carbon chain length, right? By changing the chain length of these carbon, I can bring these nanomaterial very close to each other. Basically, I can change the distance between the two nanoparticles by playing around with this. So what I can do is I can make a nice field effect transistors which can be used for either gas sensing application or memory storage applications. So by playing around with the length of terperidine chain, I can also play around how closely I'll bring these nanoparticles to each other. For example, in this case, I take a thiol terminated terperidine and that is functionalized on a gold surface. So I get gold nanoparticle that is functionalized with the thiol terperidine. Now I put a metal, either iron or ruthenium, and then I get these assembled in a nice chain form. We will see the next slide. So this is another example where I can put them onto the substrate. So I think the very first lecture by Dr. Ganesh, you all must have heard how electrochemistry can solve many of the real-time problems, right? To have the electrochemistry, the basic thing that you need is what is called working electrode or working platform. So you can have the working platform functionalized with this kind of nanomaterial, and you can actually have the self-assembly of nanomaterial on top of these working electrode and make them useful for either diabetic sensor, gas sensor, or sensing of what do you call water pollutant. Those kind of materials or gadgets you can make by self-assembly of these structures. The another one which you see on the right side is, now I have gold salt. So it is actually very easy to make a gold nanoparticle in the lab. Anyone can try it with just very small experiments. You have to take as a gold salt and have some surfactant, whatever we have it on a soap solutions, right? Some surfactant should be there, preferably thiol terminated surfactant would be preferred, right? And then the moment you add a sodium borohydride, which is a strong reducing agent, which we know from organic chemistry as well as inorganic chemistry, it reduces a gold salt into gold nanoparticle. So the moment I have like instead of surfactant, I am going to use a thiol terminated terperidine, and I have a gold salt. So now I am going to put the gold salt is made of either H or potassium, right? KAuCl4. कुछ questions है?
ये माउस कैसे रखा था मेरे को बताओ, है बुद्धि माउस कैसे रखा था?
I think somebody has turned on the mic again. Okay, please mute the mic. So once I try to do the self-assembly, because of this alkali metal on the periodic table, whatever is on the right side, we call it as an alkali metal. Whatever is on the second, we call it as alkaline earth material, right? So once we put a potassium, sodium, calcium, they do a self-assembly instead of iron at the center. So instead of iron at this place, if I put potassium also, they try to self-assemble. But the assembly
Selja ma'am, please mute करें आप.
The assembly will be very weak. Okay, I'll rush up now. And I can put a strong self-assembly, and then you can get a discrete particle also. So you can see, I can, by changing the metal, I can play around the strength of the self-assembled structure. That is what we saw with our magnetic balls. You can assemble and disassemble different structures, right? So by using either alkali metal or alkaline earth metal or transition metal, I can assemble and disassemble my nanomaterial self-assembly. So this is another example where the gold nano rods have been nicely assembled. This is what I wanted to show. This is a work from somebody has done this work. This is from a literature I have taken this. So you can nicely bring gold nanorods together, you can form a square shape, you can form like a stars or a triangle, whatever you want to imagine. You can make like a chains. All these things are possible by appropriate additions of complex or transition metal between the terpridine moieties, right? So this is one of the example. The another example where we can try to use this in a what do you call lab like ours, we work mainly on electrochemistry, right? And we work on fuel cells and batteries, right? One of the applications where we can think of this as self-assembled structure would be direct methanol fuel cells. So there will be a days will come, I'm very hopeful of it, where you have using this laptops, right? We have a battery at the back and then we connect to the power, it get charged up. But a day will come where you can have a methanol into those places and you will have a methanol filled in cage that will be inserted into the laptop, so your laptop will be powered. Like buying a petrol, you can go to any stations, buy these and then connect it into your laptop, get it powered. So that's the beauty of these direct methanol fuel cells. And people know who are working in a research, to have a effective direct methanol fuel cell, you have to bring two metals. One is platinum and ruthenium close to each other. Both are actually expensive. Platinum is very, very expensive. You know now with the current scenario, gold price and platinum price. So we need to use a minimum quantity of platinum and ruthenium, and we can use a terpridine based self-assembling technique to bring them close to each other. If they are at a certain distance, then the direct methanol fuel cell works very nicely, or the efficiency of the direct methanol fuel cells can be improved by these two catalysts. One is platinum and ruthenium, and bringing them to close to each other with certain distance. Okay. Okay. So this is what we have the scheme. So you have a gold substrate, functionalize the gold substrate with the terpridine, and then put a ruthenium salt. You have a ruthenium exposed. Now you bring in a ruthenium nanoparticle that is functionalized with the terpridine. So they nicely self-assemble, or like what we have. All these again are imaginary. We can actually have what you call characterization technique using different instrumentation like TEM, SEM. There are different instruments that can actually characterize what is the material on the surface also. Normally call it as XPS, X-ray photoelectron spectroscopy. Okay. So once I have a ruthenium nanoparticle, now the next step is I need to bring in what is called platinum, right? Again, I can put in ruthenium. After having a ruthenium at this place, I can bring in a platinum nanoparticle. So whatever you see on a brown color is a ruthenium nanoparticle, and whatever you see on pink color or something like a brinjal color is what is called platinum nanoparticle. The moment I put a transition metal between these two, they nicely self-assemble. So now I have self-assembly of ruthenium as well as platinum, again connected by metal ruthenium. These are nanoparticle, ruthenium nanoparticle, platinum nanoparticle connected to each other through terpridine linkage, and they are connected with the metal what is called ruthenium. Instead of ruthenium, I can also put iron, I can put cobalt. So based on the performance of direct methanol fuel cell, I can change this connecting metal. Also, I can change this chain length, whatever you see like a snake's, right? That's a chain length. I can change the chain length, and also I can vary the performance or efficiency of my direct methanol fuel cells. So this is one of the advantage. So this is in short, we started with the gold substrate. We first assembled ruthenium nanoparticle with the help of ruthenium salt. Then we self-assembled platinum nanoparticle with help of again ruthenium salt. In one case I can put ruthenium, in another case I can put iron or cobalt also. So it all our choice only, and we all going to look at how the change of metal affects the performance of direct methanol fuel cells. Okay, so now I've taken just simply terpridine, self-assembled gold nanoparticles, self-assembled magnetic nanoparticles, and self-assembled some of the metals for fuel cell. In one case, we saw applications in drug delivery kind of systems or water purification system. In this case, we have seen where it can be used in a direct methanol fuel cell. So that, as I said, if you have nanoparticle as such, this is not going to be useful. You need to put them or bring them together in a useful material or useful form, and self-assembly would be one technique, and that can be initiated using this terpridine molecule. If I'm boring, I'll stop at this point. Okay, and you can also put ask me questions. So we started off with the rangoli. Okay, so I can actually have a rangoli with the terperidine. So these are people, of course I don't know how to do a rangoli, but girls teachers they know how to do the rangoli. So by connecting each dots you can have a nice structures, right? Nice rangoli. Same way, by connecting each of these terperidine molecule I can have beautiful structures like this. Hopefully I'll store it somewhere here so you can see the structures, right? So I'll stop at this point. If you have any question, you can ask me. Okay, hopefully it goes to the next slide. So I take this opportunity, as I said, our director, Dr. N. Kalaichilvi, for the opportunity, and organizing committee, especially Dr. Rangappan, and one of my PhD students, Manju, and many MSc and project assistant who have contributed to some of the work I presented today. And also we are very thankful to CSIR and Department of Science and Technology for their funding. And of course, I'm extremely thankful to all the teachers. Because of you only, we all are scientists, engineers and all. So thank you, and thank you for your attentions and patience throughout these presentations. Thank you, sir.
Thank you, sir. Thank you.
so much.
Thank you very much.
Presentation.
Thank you so much.
Thanks a lot, sir.
Thank you. So you can
Thank
ask
you
me
so much, sir.
questions if you have.
Thanks, sir.
Thank you very much, sir.
Thank you very much. I have a doubt, sir.
Yeah.
Thank you,
Sir,
sir.
I had a doubt.
Thank you, sir. Thank you very much.
Sir, am I audible?
Thank you, sir.
Yeah.
Sir, I had a doubt.
Please
So
go ahead.
in CECRI, that is the CSIR department, so how you will apply the energy to break down the bond, sir? I had a doubt.
Yeah. By applying a potential, you have a carbon-carbon bond. What is a carbon-carbon bond energy is?
Okay. Some
Organic teachers,
uh,
how many kilojoules it is? Okay, you go and search.
110.
110.
16 to 40 kilojoule,
Yeah,
depending upon
kilojoules per mole.
and
It's
NH
close. Yeah.
FH
So
bond.
if you apply some amount of potential, you can break this bond. Now you can actually ask another beautiful question, which is, sir, if the energy that I apply to break this bond is useful in terms of the product I get out of it, that we need to work out. That's what is called statistics, or what do you call marketing thing, right? The amount of energy that you apply to break the bond should be less enough than the product that you get out of it, right? Then only the product will get into the market. Then only it's a viable technology. If you apply more energy to break the bond and whatever you get out of it is very expensive, then the technology may not be viable. Okay.
Sir, why don't you allow us to actually, that is by seeing how they will make, how the bonds, this layers will be formed and all these things. If you allow us by visiting your CSIR, so definitely we will be very much benefited.
Definitely, sir. Please contact Dr. Angappan, sir. He is the one who does this also. These kind of activities also done in CSIR, Central Electrochemical Research Lab. You can come have a visit. And also there is something called INSA, right? INSA is a academy, science academy in India, through which you can also get a fellowship or scholarship to do a research in these kind of national labs for 3 months time. Actually, 56 days, I guess.
Okay. Thank you, sir.
Many teachers come to our institute to do research. बहुत लोग आते हैं इधर INSA fellowship.
Hello, sir. Good morning, sir. I am MG Reddy from ZIT Mumbai, sir.
Please, sir, tell me.
Sir, my question is, direct methanol fuel cell is there in the market, sir?
बहुत ज्यादा माइक ऑन है. आपका क्वेश्चन है डायरेक्ट मेथनॉल फ्यूल सेल, क्या पूछना चाहते हैं आप, प्लीज?
Whether the direct methanol fuel cell is already the discovery is there, sir? Or any practical applications are there in the society, in the market?
Market, it is not there, but there are few companies who can afford this.
They're in our daily routine, sir.
Yeah. There are few companies who can afford these kind of technologies, and they are using direct methanol fuel cells in some of their premises, right? Not everybody can afford this, mainly for safety reasons and also for affordability. But wherever you want to reduce these carbon dioxide
For
emissions,
all of
that's
you,
what we talk
आप
about,
एक
right?
एक खुला हुआ
We
लेकिन अभी
want to
आपको
reduce the
करना नहीं
carbon
है
dioxide
स्टार्ट
emission.
दैट मीन
Please,
या
madam,
मत लो
कोई तो mute कर दीजिए, please. Yeah, wherever you want to reduce these carbon dioxide emissions, or you want to have an alternate energy generation other than nuclear or from water, then these are the energies that can be used. Direct methanol fuel cell is in use, but not in a commercial use like as we get it in any e-card websites.
Okay.
Sir, मेरा
So that means these kinds of cells are far more than normal cells.
Sir is putting a hand. Please go ahead, sir.
Sir, these cells are
बहुत
normal cells.
sir
Sir,
मेरी
one sentence.
sir
One sentence I liked very much, sir. Weaker the bond, one bond very weak, and many bonds, though they are all weak bonds, what we teach in chemistry classes, whether they are dipole or whatever. You said one thing, very excellent example. So far, we did not use in our classroom. That we find it very difficult to explain to the children. The rope, single rope and many ropes joined together. And I want to coin one more, uh, national integration. In spite of all the languages and all the states, India is one. Means all forces joined together. It is very strong. And your explanation, fantastic, sir. As you mentioned, right from Ganesh sir, we chemistry teachers are enjoying like anything. I believe all of us will cooperate with me because what we teach is only exam point of view in the classroom
completely
situation.
agree, sir. Completely agree with you. Completely agree with you.
And almost all the topics are very much connected. After 30 years of MSc, I have been enjoying your CSIR-CECRI professors, researchers, and you are so obedient. You are because of us, means teaching community. So that shows your humbleness. Excellent, sir. Excellent classes. We are very happy, sir. Thank you, sir.
Thank you for your kind words, sir. Thank you. But as I keep saying, you are the one who promote people like us, right? We go to school, we learn through you, teachers, and that's how we become a good in our professions, whether it is a scientist or whether it is an engineer. But you give the what do you call base to us. You self-assemble us actually.
Sir, actually, at first I want to ask a question.
Thank you for your great comments.
Sir, at first I wish for hello.
Yeah, please, sir. Please.
बोलिए
Volume is very low, but I can hear. Please go ahead, sir.
Yes. सर सबसे पहले तो आपको थैंक्स दें, आपके अच्छे एक क्वेश्चन मेरे मन में आ रहा था कि आजकल जो है
सर कोई तो बीच में माइक ऑन कर दिया तो बराबर सुनाई नहीं दे रहा है, प्लीज आप दोबारा बोल दीजिए।
बहुत सारे वॉशिंग मशीन की कंपनी सिल्वर नैनो डिवाइस को यूज कर रहे हैं। मेरा क्वेश्चन ये था कि ये सिल्वर नैनो एंटीबैक्टीरियल पर्पस से उसमें यूज किया जाता है। ये सिल्वर नैनो पार्टिकल का असेंबली तो उस वाटर मॉलिक्यूल के साथ होता है या डिटर्जेंट और सोप जो डालते हैं उसके साथ होता है? और यदि यह एक्चुअल में यह डिवाइस वर्किंग होता है तो क्या इसका डोमेस्टिक यूज हम कर सकते हैं क्या एंटीबैक्टीरियल पर्पस से?
हाँ सर, एंटीबैक्टीरियल पर्पस के लिए कर सकते हैं। वॉशिंग मशीन में जो वॉशिंग मशीन एडवर्टाइजमेंट करते हैं हमारा मशीन में सिल्वर नैनो पार्टिकल है तो ड्रम के ऊपर वो कोटिंग रहेगा। वो जो जैसा हम लोग बात करते हैं सेल्फ असेंबली का, वैसा भी सेल्फ असेंबल किया रहेगा, नहीं तो पेंट जैसा उसके ऊपर कोटिंग रहेगा, लेकिन उसमें सिल्वर नैनो पार्टिकल रहेगा। सिल्वर नैनो पार्टिकल के साथ कुछ भी माइक्रोब्स आएगा वो टूट जाता है, तो देन इट शोज एंटी माइक्रोबियल एक्टिविटी। ओके, वी आर टॉकिंग ओनली अबाउट माइक्रोब्स, not talking about virus. Okay, so don't get confused with the virus in the current situation.
Yes sir, it is not for the virus, but only the wall of the tank is coated with the silver nano particle.
I understand, or if I get the question correctly, is it only silver nano? There are few other like gold nanoparticle of some sizes also some antibacterial activity. But whenever it comes to antibacterial activity, normally people use either silver or copper. Okay.
No, sir.
So
He's
that is,
asking. Sir, he's asking whether the surface only is coated with the silver nano.
Yes. Only the surface. There is nothing else should be there. Same thing. There are some water companies. They are also selling water purification systems, RO system. They sell either a copper embedded instead of plastic. They will have a copper vessel, storage vessels. Or few people they have something called silver cartridge. Right? If you open the thing, they have a carbon to which there will be silver nanoparticle will be embedded. Yes. It will be coating on the surface. Yes.
So assembly, just any liquid if put in that tank, that will be silver nano, that will be mixed with the silver nano particle.
You can like जैसा मैं एक एग्जांपल बताता हूँ, मतलब कंपनी का नाम भी बोलता हूँ, लाइक वैनिश यूज करते हैं ना, वैनिश जैसा कुछ भी मटेरियल हम लोग यूज कर सकते हैं, उसमें भी यू कैन ब्रिंग इन सम अमाउंट ऑफ नैनो पार्टिकल एंड दैट विल व्हेन यू डू द वॉशिंग के साथ वो एंटी बैक्टीरियल एक्टिविटी भी कर सकता है, जैसा ड्रम में भी कोटिंग रख सकता है, नहीं तो वैनिश जैसा या सर्फ जैसा या एनको जैसा यू कैन ऐड एक्सटर्नली आल्सो, वो वाटर में ओके वो इमल्शन जैसा होता है, तभी भी वो माइक्रोब्स को किल कर सकते हैं, कैसे भी उसको अप्रोच कर सकते हैं. इट ऑल डिपेंड्स ऑन एज आई गो बैक टू कॉस्ट, हाउ मच इट कॉस्ट टू डू दैट मैकेनिज्म, दैट्स ऑल. यस, इट फाइनली ब्रेक्स डाउन दैट.
Thank you, sir, for excellent class.
Sir, one request from my side, sir. This is Venkatesh.
Yeah, Venkatesh. Yeah, please go ahead, sir.
Sir, whenever you talk about these fellowships, no, sir, school teachers are not much encouraged, sir. So wherever the forum is possible, you just put in a word, sir, from your side. Whenever you all meet these people, that school teachers should also be promoted. Say, as a student, I have taken part in summer research fellowships from Academy of Sciences. But as a teacher, I think assistant professors are encouraged, etc. at degree level. But PGTs are not encouraged. So if you all can put up this in a proper forum, it will be more useful for us, sir.
Definitely, I will also put into it from our side. But Jigyasa is one such a platform, right? The CSIR has coined the Jigyasa only for that purpose. Of course, you can also express your views, saying that you would like to do a small research with the time that you're off from.
Because I have prepared terperidine complexes as a part of my project. Okay. But I have not gone into the level of nanoparticle assembly.
Okay.
So I am interested, but I don't have the opportunity. That is what I am trying to tell. So
yeah, and I understand.
Yeah.
That.
So if such forums are given for us, definitely we'll also improve our knowledge and we will convey it to students also.
Sure.
So that forum has to be.
और सर नहीं तो बंद करते हैं अभी.
Sir.
Yeah, please go ahead.
Sir, first of all, thank you for an interesting lecture. But we teachers also face questions like students, they want to know how to go to the research field, you know, and what kind of subject combination or what kind of courses they should take so that in future they can go for a research field if they want to go to become a scientist. Everyone tells them how to prepare for becoming an, if they want to become an engineer or doctor, but they do not get that much guidance that if they want to go in a research field, what kind of stuff they have to take, what kind of combination. If you can inculcate this information also in this lecture or in future, it will be helpful for us to explain this to our students.
Sure, madam. Yes. Let me answer. बहुत सही question पूछा आपने. बहुत everyone knows how to become an engineer or how to become a doctor and all. They plan that from the beginning, and also maybe parents का knowledge ज़्यादा है उसमें. Like if they want to make their students into engineer or a doctor, they have known or they collected information. जब scientist बनना है या कुछ chemistry में research करना है, maybe they may not know too much. The reason is in terms of perks, it's not very lucrative as you become a doctor or engineer, okay? But you can enjoy what you do. I'll tell you how to approach this. So after 12th standard, there are many IITs that conduct exams. Like one is a JEE exam. If the score in the JEE exam is little low, then you can get into what is called integrated courses. where you do 5 years chemistry, physics, or anything of your choice, right? That is one way. The another way is there are a lot of ICERs that have come up. They also conduct separately एंट्रेंस एग्जाम्स. आइसर का भी एंट्रेंस एग्जाम रहता है. वो एग्जाम लिखने के बाद आप आइसर में भी जाके रिसर्च कर सकते हो. अगेन इट्स इंटीग्रेटेड कोर्सेज फॉर 5 years, right? If all these opportunities goes off, not every students let's say become eligible for engineers. So what they'll do is they'll join BSc courses, right? After BSc, again there is an opportunity. All the IITs and ICES conduct exams where you can do MSc in their institutes. I'm talking about big institute where the futures will be very nice. Of course, there are a lot of private universities or there, colleges are there where there may be entrance or there may not be entrance exams, and also you can join for a MSc program. So after BSc, you can join for MSc program. Once you get into IITs or ICERs or IISCs, Indian Institute of Science, Bangalore, all these institute conduct what do you call or conduct integrated courses. Once you clear these courses, then the future they themselves will know. The students will follow certain track by which they either do register themselves for a PhD program in India by clearing up CSIR UGC exam, right? Because now the scholarship is very nice. It's very lucrative. 34,000 is what they get as a JRF, Junior Research Fellowship. After your MSc, even you may not get that much money in any job, but Government of India is promoting research in India, and CSIR is one such institute, right, where you can join as a junior research fellows with the scholarship or fellowship of 34,000 per month. I think that is increasable after 2 years of your tenure. Then you become senior research fellowships, and I think it goes to 36. Don't take me on for these numbers, but it's somewhere around 30,000. Okay, roughly the figures are 30s.
Right, sir.
You're correct, sir. Plus HRA.
Thank you.
34 plus HRA.
Yes.
Sir, very good.
Sir.
Thank you, sir.
Excellent,
Yes, sir.
Excellent.
Sir.
Well said, sir. Well said, sir.
Sir, thank you for your wonderful lecture, sir. First, sir, my query is that, sir. Sir, am I audible?
Yes, audible. You're audible.
Okay,
please go ahead.
Okay. Sir, it's my request, sir, that in workshops, sir, there was a topic more from the physics, chemistry, sir. I am PGT Bio, sir. Please, I request that, sir, please include some more topics of biology, sir, also. That so this is
I will convey this to Angappan, sir, to include some biology in the next courses.
Yes, sir, because there are some topics like, sir, as you say, in the nanoparticles, or therein, sir, we have a chapter called biotechnology in class 12th, in which, sir, we tell the students how that the gold coated nanoparticles have been injected into the cells by the technique micro injection technique. So, sir, if you include this type of techniques also little bit in your workshop, sir, that will enlighten us to transfer the same knowledge to students, first thing. And second thing, sir, as these techniques are very new to the India, and sir, these type of practical skills are not available at school level. So please, sir, organize some hands-on training practices for the students also a little bit more, so that they can expose to more these kind of practical techniques. I'm saying that if people like you who are the sir, expert in your field, sir, if you can possible organize some 3 or 4 days workshop for the students for this hands-on experiment, and they can see, sir, these devices like micro injection technique, ballistic gun method, so that this will create an interest among the students. Curiosity will develop, sir.
Point is taken. Actually, कभी तो हम लोग plan किए थे like mobile labs. I'm not very sure where we are on that, but there were ideas like this to promote science in and around and teaching communities with the use of mobile labs, where we will be having a small lab setups. Will allow teachers and students to come and do some experiments. For example, like making gold nanoparticle. As I said, it's a little easier. You can make a gold nanoparticle and have a hands-on experience of making that. So definitely the point is taken, sir. We will try to do it in the future the best, and also try to reach you.
Yes, sir. Sir, one thing is that, sir, the technology, sir, that you are saying, that is very reachable in the very, sir. But sir, I am speaking from, sir, Mizoram. That's a little bit, sir, remote area, sir. So, sir, if the workshop you organize the workshop like this, and if you include this topic, sir, it will be very sir, a guiding experience for as a teacher for me, and sir, for students also, because if you that recording will be shared, that we can also share that recording with, we can also share some of the part of this recording in which you show
I
these
think,
techniques to the students also. And sir, people who are sir, like you, if you express the things, sir, that's are far beyond the excellence, sir. They are far beyond our knowledge, sir. That you express is very, in a very layman language, sir. You express the tough things, and that is very, sir, expressive and innovative, sir. These are the, sir, my.
Thank you for your.
बढ़िया बोले भैया, 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 बढ़िया बोले भैया, बढ़िया, very nice. And sir, one thing.
Thank you for your comment. We will
one
consider
question,
this. And some of these lectures have been actually recorded. I'm sure if you write an email to the organizing committee people, they will be able to send you those records.
Sure, sir. Sure, I will.
File sharing system.
Sir, I will also forward this mail ID to our regional officer.
Yes, yes.
Sir,
and if
I will try my level best, sir.
Sir, you told gold chloride, Rm chloride, sir.
Sir, okay.
Rm chloride, sir. Can I?
Yeah, it's called HAUCl4 or KAUCl4. Yeah.
Sir, the problem is normally at school level, that is +2 school level, I don't know about its cost, Rm chloride. Costly elements generally we don't go for. Of course, silver nitrate को खरीदने के लिए principal को मस्का मारना पड़ता सर. बात बता रहा हूँ मैं. So what I mean to say, our funds are sometimes they may not, Rm chloride and whatever chemicals you mentioned, some of their beyond the level of +2 levels. That's the problem.
मैं वो समझता हूँ एक्चुअली. देखो एक बात है जी, लाइक सब एक्सपेरिमेंट करके भी देखना नहीं चाहिए. देयर आर लॉट ऑफ यूट्यूब्स दे वेयर पीपल शो दैट एंड you can teach the kids using those YouTubes also. They'll get a knowledge. Of course, I completely agree with you. Not all the schools or not all the principals are kind enough to support. And those cases, of course, you can always cherish the students with the YouTubes or videos like what you're seeing right now. Some of these are recorded. So you can share some of these with your students. Again, as I said, sir, you are the one who self-assembled the students to engineers and doctors and, scientists. So whatever you ask, definitely we'll try to do it, sir. No problem.
Thank you, sir. Thanks a lot, sir. Very nice, sir. Particularly your photos are fantastic, sir. Your PPTs, particularly that surfactant emulsions, very excellent, sir. Thank you, sir.
Thank you.
Excuse me, sir. Sir, yep. Please share your PowerPoint, sir.
Please share.
Yes, sir. PowerPoint and all learning emails or WhatsApp group, sir.
Yes,
whatever you please. It was very interesting, sir. Thank you so much.
Okay, sure.
So thank you, sir. A wonderful session and fruitful session, sir. I'm Gopal Reddy.
Session will be starting up soon now. 11:30. Okay. So, all right, sir. Thank you.
Thank you, sir.
Thanks.
Thank you, sir.
Sir, thank you so much, sir. Thank you so much.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thanks a lot, sir. Thank you so much, sir.
Thank you, sir.
Sir, when will be the next session?
11:30, sir.
Okay.
This session will start at 11:30.
Okay.
We'll stay for that.
Angappan sir.
Yes,
Angappan
sir.
sir.
Yes, sir.
I am MG Reddy from ZIT Mumbai, sir.
Yeah.
Sir, I requested several times, sir. Please add me in WhatsApp group, sir. Please, sir.
Okay, sir. Okay, sir. One by one, I am going done. So
No, sir.
I will
Even
check it.
yesterday also, I sent message through your personal WhatsApp number, sir.
Yes, sir. Yes, sir. Yes, sir. I will do it, sir. I will do it.
Okay, thank you, sir.
Sir, will you send the recording of all these programs?
So we are processing. After the program is over, next week we will proceed. Okay.
Okay, okay, sir. Thank you very much.
What time is the next session?
The next session will start at 11:30. 11:30. We wait for 10 minutes.
Yes, sir.
Yeah.
Vasudevan? Vasudevan?